Hey everyone, welcome back. So imagine spending hours building your Terraform project and then realizing your VM password is hard-coded inside like Azure Key Vault exists. So in this part, we'll generate a VM password automatically, store it securely in Key Vault, and use it to deploy a Windows VM. And while doing that, we'll also finally make sense of for each and count using a real Azure scenario instead of a boring theory. Alright, let's get started. So now let's talk about Azure Key Vault and why it's so important in real cloud environments. Think of Key Vault like a secure digital safe for your infrastructure. Instead of storing passwords or API keys directly inside your Terraform code, which is a very bad idea, we store them securely inside Azure Key Vault. For example, companies use Key Vault to store VM passwords, database passwords, API keys, certificates, and encryption keys. On the left side, you can see the main things we can store: secrets, key, and certificates. And on the right side are some of the biggest benefits. One big advantage is centralized security. Everything stays in one secure location instead of being scattered across the scripts and files. We also get access control with Azure AD integration, plus auditing and monitoring, so we can track who accessed what. And honestly, soft edit is a lifesaver. If somebody accidentally deleted a secret during a production issue at 2 a.m., hopefully not us, so we can still recover it. And at the bottom, you can see how the process works. Terraform on an application requests a secret. Key Vault checks permissions, returns the secret securely, and then the application uses it. And that's exactly what we are going to do in this demo with our VM password. So this is the part where almost everybody gets confused when learning Terraform. For each, we count. And honestly, when I first learned Terraform, I was also thinking, why do we even have two different ways to create multiple resources? But the difference actually becomes simple once you see it in the real scenario. Let's imagine a company environment. First scenario, we need environment like dev, test, staging, and prod. Each one has different names and maybe different configurations. That's where for each becomes perfect because each resource is unique and identified by a key. So instead of resource 0, 1, 2, we can have dev, test, and prod. Much cleaner and easier to manage. Now on the other side, imagine we just need three identical resources, maybe three NICs, three public IPs, or three similar VMs. That's where count make more sense. Terraform simply creates resource 0, resource 1, and resource 2. So the easiest way to remember this is use for each when resources are unique, use count when resources are almost identical. And in our demo, we'll actually use both. For each for Key Vault secrets, and count for repeated network resources like NICs or public IPs. So this scenario, we are going to build a small but real-world Terraform deployment in Azure. We'll create a Windows VM, but instead of hard coding the admin password inside the code, we'll generate the password automatically and store it securely inside Azure Key Vault. Then Terraform will retrieve that secret from Key Vault and use it for the VM deployment. We'll also use for each to create multiple secrets dynamically inside Key Vault. And for the networking side, we'll use count to create multiple similar resources like public IPs and NICs. So this is very practical example because we are combining security with Azure Key Vault, modular Terraform design, and real usage of for each and count. Let's jump into the VS Code and build everything step by step. So this is very practical example because we are combining security with Azure Key Vault, modular Terraform design, and real usage of for each and count. Now let's jump into this VS Code and build everything step by step. Alright, now let's go into VS Code and build this step by step. The goal is simple. We want a Windows VM, but the VM password should come from Azure Key Vault, not from hard-coded VM code. We'll also use for each inside the Key Vault module for multiple secrets, and count inside the network module for repeated public IPs and NICs. So first, in the root main, I'm starting with Azure provider and also using random provider because I want to Terraform to generate the VM password for me. Here I create password with random password. This password will not be typed manually. Terraform generates it, and then we send it to Key Vault. Next, I create resource group. This is where all part 8 resources will live. After that, I call the network module. So I'm passing resource group name and location and instance count. The important part here is that the network module will use count to create multiple public IPs. And next, after that, I call Key Vault module. Here I pass the Key Vault name, tenant ID, object ID, and secret map. So inside this secrets map, I'm passing 3 secrets. The most important one is VM admin password, and its value is coming from the generated random password. And then I read that same secret back from Key Vault using a data source. This is the part where Terraform. Let's go to network. So this module creates the VNet and subnet first, and then here is where I use count for public IPs. If instance underline count is 2, so then here is where I use count for public IPs. If instance count is 2, Terraform creates 2 public IPs. The name uses count.index plus 1. So the names become PIP-1 and PIP-2. And next I use count for nicks. This creates the same number of nicks. Let's go and open the Key Vault module. First, this module creates the Key Vault. Then we create the access policy. This gives our current Azure user permission to get, set, and list secrets. And now, this is the important part. The secret resources uses for each. Terraform loops through the secret map for each item. Each key becomes the secret name, and each value becomes the secret value. So if I pass the 3 secrets from the root module, Terraform creates 3 Key Vault secrets automatically. This is why for each is better here. These secrets are unique. They have names and different purposes. Let's go to VM module. This module creates the Windows VM. The VM receives the admin username and password as inputs. The important part is that this module does not know and care where the password came from. It just receives it. But from the root module, we know the password came from Key Vault. So this keeps the VM module clean and reusable. And here I only need to set values like the Key Vault name and instance count. And let's go and run our Terraform code. Okay, let's go for Terraform plan. Terraform plan shows what Terraform is going to create. Here I want to confirm the Key Vault, secrets, network resources, and VM. And then we can go for Terraform apply. So we can see all of the items that Terraform is gonna apply on Azure portal. Let's go and run Terraform apply. So Here we can see all the resources Terraform created automatically: networking, Key Vault, public IPs, NICs, and also Windows VM. So let's go and open Key Vault. Okay, let's go and open secrets. So we have VM admin password here and other secrets. We can see the secrets and that were created dynamically using for each. Instead of manually creating each secret one by one, Terraform looped through the secrets map and created them automatically. So let's open the VM admin password. So you can see the current version. And if I click on it, we can see the secret value. So here the VM admin password that Terraform generated automatically and stored securely inside Key Vault. So let's go and copy this password of the VM, and we can go here and check if we can connect to the virtual machine. So we can use Bastion to connect to the virtual machine. Is Azure user. We use it in our Terraform code. So I paste the password and let's connect to the virtual machine. Connection successful. We used, so let's see if we can connect it to the virtual machine. Yes, we could connect to it. All right, everyone. That's it for part 8. We used Azure Key Vault with Terraform, learned for each account, deployed the infrastructure, and connected to the VM securely using password stored in Key Vault. And in the next part, we are going to move into Terraform validation and error handling with Azure Storage. We'll create storage accounts, blob containers, and other Azure storage resources. But more importantly, we'll learn how to validate Terraform inputs properly and handle errors before deployment. Because in real world environments, preventing bad configuration is just as important as deploying infrastructure.